Hi guys, these next tutorials are about the electromagnetic force, which we're going to break up into two sort of sub-forces, electricity and magnetism. Here's a quick refresher about what we already know about forcers. If we look at this balloon car, you should know that if we make a dot in the center, we can show all the forces acting on this balloon car. We've got the force of gravity pulling it down. We have a normal force from the ground pushing up. We have an applied force, which is coming from the balloon releasing air and pushing the car actually this way. Because as the air comes out the back, zoom, 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 the car is going to get pushed in the rightward direction. And there's also a force back there resisting the forward motion of the car, and that's the friction force. So the electromagnetic force is in this picture. Three of the forces are the electromagnetic force. Here they are. This one, and this one. Because the electromagnetic force is really a force caused by the particles that make up atoms. So all of the forces, the friction, the normal force, and the applied force are really coming from little tiny particles inside of atoms that can push and pull on each other. So electromagnetism is carried around inside of atoms, and since all the matter in the universe is made up of atoms, all we have to do to understand electromagnetism is take a sample atom. This is an oxygen atom, and you can see the charges that are inside the atom are marked out for you. You've got in the center here the nucleus of the atom, and it contains a group of charged particles called protons. Protons have a positive charge. That just means that they have one of the two charge types. There's two types of charge, a positive and a negative, and they're opposites. We don't really know exactly what a charge is. All we know is that charges carry around forces with them. Charges can push and pull on each other, and they have two different ways of doing that. Sometimes they pull together, sometimes they push apart, so we know that there are two different kinds of charges. The other one is the electron. This particle floats around on the way outside part of the atom, and electrons have a negative charge. So the important thing to realize is that in any atom, you've got positive and negative charges. Usually, these charges are balanced with each other because it turns out that positively charged things attract negatively charged things. If you have a positive charge and a negative charge and you bring them near each other, you will find that they pull together, and that is one of the types of the electromagnetic force. That's an attractive force. If, on the other hand, I take two protons and bring them close to each other, they want to push apart. That's also the electromagnetic force, but it's the repulsive type of it. They repel one another. And you might say to yourself, okay, so if they push apart when they bring them close together, how come they're all stuck together in the nucleus? And that is weird, but that's because there's another force in the nucleus that we don't learn about in this class called the strong force. The strong force is stronger than the electromagnetic force, and it holds those protons together. But the strong force only acts over really tiny distances. So you have to be inside the nucleus of an atom before you can feel it, and we're just not that tiny, so we never do. But this is important because the protons are stuck in the nucleus. They're stuck to each other. So generally speaking, the electromagnetic force, when we feel it, it's not protons we're feeling. It's electrons. Electrons, if we were to bring two of them near each other, would repel each other as well. So two negatively charged electrons would also repel. And like I said before, if I bring one of each near each other, they will attract. So you can see charges push and pull on each other. That's the main thing to take away from this part of the tutorial. Charges push and pull on one another depending on whether or not they're alike or different. Like charges repel, and opposite charges attract. Electricity can be in the form of something called a current, or it can be static. If something is in a current, it's flowing, it's moving. So these are flowing charges, specifically flowing electrons. If we get a bunch of electrons moving in a line, we have an electric current. Static electricity, on the other hand, is a charge buildup on a surface. And static literally means standing still. So when you have a static charge, what you've got is some object, say a balloon. It's a terribly shaped balloon, but you get the idea. And this balloon somehow has picked up an excess of negative charge. And then say your teacher's hair over here has somehow, and we'll talk about how in a minute, picked up a positive charge. And as a result, because these are oppositely charged objects, they're attracted to each other. So in this case, electrons aren't flowing, but there's an abundance of electrons on the balloon and an absence of them on the hair. How does that happen? Well, it happens actually by rubbing, because it turns out that electrons are very easy to rub off of atoms. Let's take a closer look at an atom and see if we can see why. Okay, so here's that complicated drawing of an atom again. I'm going to simplify it way down to just what you need to know for electricity. Basically, what you need to know is, in the center, the nucleus is positively charged. And that positive charge can't go anywhere. It can't move. It's stuck there because the strong force holds all of those positively charged protons together. Way out in the outer reaches of the atom, far, far away, further away than I can actually show on this iPad, are those electrons, and they are negatively charged. And they're way out here somewhere. Those negatively charged electrons can actually easily be stolen from the atom. They can actually be rubbed right off with just a little bit of friction, depending on what's doing the rubbing. You've probably noticed that static electricity sticks to some things and not to others, and that's going to become an important point in a little bit. But just realize that electricity of any kind is electrons moving from one place to another or getting stuck somewhere where they aren't normally found. And that all can happen because these negatively charged particles on the outer part of an atom are easy to move, as opposed to the positive charge in the middle, which can't be moved at all. Some materials are considered good at letting electric current flow through them, and some are considered bad at letting electric current run through them. We call them conductors and insulators. A conductor allows an electric charge to move freely from one place to another, and an insulator doesn't allow an electric charge to move easily from one place to another. Pretty simple, right? Conductors are made up of atoms that happen to have loose, free electrons. Those are electrons that are not tightly held by the atom and that can break off very, very easily and move around, like this guy, or this guy, or this guy. Insulators are atoms that just so happen to have very few free electrons, and so there's really not this ability for stuff to move around. So what kinds of things make good conductors and what kinds of things make good insulators? There is no perfect rule for figuring this out for a beginning student, but generally speaking, conductors, which you see on the left-hand side, over here, conductors, generally speaking, they are metals. And insulators, generally speaking, are nonmetals. Again, this is in general. So if you look at these pictures on the left-hand side, we've got all sorts of metallic things. I have, to be quite honest with you, no idea what these things are supposed to be, but okay. These are wires down here. And then, we've got, this looks like gold bars and some copper wire. Insulators are things like plastics, plastic bottles, plastic bags, glass. This is, I think, a piece of mirror is what that looks like. And you've got wood also. All insulators are things that you think of as not being very good at carrying a charge. And you instinctively know that metals are more likely to shock you than nonmetals are. This is why cords that contain wires are designed the way they are. Cords or wires are designed so that the inside is a good conductor, usually made of something like copper, and the outside is a good insulator made of something like rubber. And that way, the electric current can flow through the copper without escaping to the outside. And this is what protects you from getting a shock when you touch it. So there's two kinds of electricity, as I mentioned. There's this flowing kind, where the electrons are able to move from atom to atom through a substance like copper. And this is what happens when we have a wire. We have some sort of positive charge that attracts our electrons to it. And those electrons move in a line through the copper. And they're literally jumping from atom to atom, displacing an electron in one atom and moving to the next atom, and they move towards that source of positive charge. And that's an electric current. And you can use an electric current to do all kinds of things, because moving electrons are a form of kinetic energy. Static electricity, on the other hand, can also cause motion and give you some kinetic energy, but only if you bring charges that are either alike or unalike near each other. As I mentioned before, if I rub my hair and this balloon together, some of the electrons from my hair will move to the balloon. My hair has some free electrons, and those free electrons are able to move. My hair is actually a pretty good conductor. The balloon is a pretty good insulator. It doesn't like to have electrons move through it, so it won't give any away. So the electrons are going to rub off onto the balloon, leaving behind a mostly positive charged particle called the proton in my hair. So now, these electrons, now that they've moved, they're now going to be giving a charge to that balloon, a negative charge. And as a result, the negatively charged balloon will be attracted to my positively charged hair. And so we get motion. The balloon and the hair move towards each other, and that's another form of kinetic electrical energy. Until we bring them near each other, though, we would say that this energy is stored potential electrical energy. Whenever you separate charges and bring them apart from one another, their ability to eventually move together or repel each other, if they're like charges, will result in motion. And that's it for electricity. I'll meet you in the magnetism video.